What I want to, this is something, I mean, I understand very well that this is something that you can't see happening because of the nature of the limited speed of light, and this is something that travels at the speed of light. So basically this comes up and hits you from behind, as it were, and you've got no warning.
Yeah. There would be only one way I could see that you could have warning. If, let's say, a hypothesis, there were civilizations in the galaxy, there was intelligent life, that recognized the importance of knowing when these were coming and set up outposts at different points, that were able to relay a signal that was superluminal, in other words, travel faster than the speed of light, to get the warning here so we know exactly when the next one was going to arrive. That's possible.
Okay, well, we actually have a witness, Jake Simpson, we call him Jake Simpson, who has said that they did send a superluminal craft outside this solar system, and that they have seen a wave approaching. He called it a wave. We're not sure if he actually meant a wave, but in essence, they saw something headed toward us.
And who is they?
The people that he works for in Black Projects, basically. So this is Jake Simpson. So that was one of the reasons that we were sort of interested in hearing your theory, because in many ways it seemed to coincide with what he was saying they saw.
And how close is it, did he say?
In this period of years between now and 2017.
Yes, it was very interesting. It was a conversation which I personally had with him last October when we met. He's not a physicist. He's an intelligent man. He's worked for Black Projects on the inside, and he's saying things to us that are at the limit of what he can say. What he said was that there is a wave coming, and he stressed that the wave was a sort of loose term, as a metaphor. He said to think of it in terms of a wave. He said like that. I have no idea whether he's acquainted with your theories.
Well, this is the problem with Black Projects. They're completely isolated from the rest of the world, and they discovering things as if they found them themselves for the first time, while everyone else who may have been doing a lot of work on the subject is left out of the loop. And the only people that lose out are the human race, basically, because here's I've been working on superwaves since 1979, so what, 30 years, and I would be happy to work with them you know, I believe I'd have something to contribute if they did have some information like that.
Sure.
Be able to
So,
interpret
well,
what
I
they're
mean,
saying.
actually, is it possible that they are following your work, benefiting from
I'm sure
it,
they
etc.?
bought my book, and it's circulated among the Black Project scientists.
Especially if your parents, as you said, worked in the Manhattan Project. They're
Well, regardless of that,
okay.
I think they're searching for new ideas all the time to sort of funnel this into what they're doing. I think to some extent they realize that they don't have all the ideas, that there's interesting stuff out there. But I think it's that really people should be brought in from outside to help on this. You know, this is something we're, you know, why keep it secret? We all want to help out to prepare for the next event.
Okay.
Like personally, my standpoint is, from all the work I've done, I can only talk about probabilities, that we are overdue for one. But I don't know when it's going to come, because I'm looking at the past record, I see the cycles, I see when the last events occurred, and I can say that within the next 400 years, there's a over 90% chance we're going to have one. Whether it's a small one or a large one, I don't know. So that's the best I can do. Now, I would be saying something entirely different if I had real evidence that there was one, that somebody had actually detected one. Well, Starburst Foundation, for example, would go into high gear to say, you know, we've got to start preparing. We're not prepared for something like this. Not even for a Carrington event solar flare, which could wipe out all the power systems if we had one.
So are you saying that the superwave would result in the wiping out of the power systems?
Oh, yeah.
What other effects would it have?
The thing is, the superwave, on its forefront, would have a very dense sort of shock front of cosmic rays. And this would have also an EMP, what we call EMP, electromagnetic pulse, associated with it, similar to what a high-altitude nuclear explosion would do in the atmosphere. And when this arrives, it's going to create similar phenomena, just like the starfish explosion. I believe it was near Hawaii, and when the EMP wave arrived, there were whole sections of the island who were having blackouts as a result. It also would fry electronic circuits, phones would go out. We've had even smaller events like gamma ray bursts affect the communication systems and do damage to our communication system. So something like this would pretty much roast all the satellite equipment we've got. Cell telephones wouldn't be working, TV would be off the air if it depended on satellite. Perhaps telephones would continue to work if it was fiber optic, it was insulated from this sort of thing. Your power lines would pick up the pulse, the wires would have a huge voltage surge, which would fry the transformers, the step-down transformers to go from your million volt voltages down to your voltages you use in your house.
Wouldn't it always also affect the cars that we have now?
The cars that are all now with chips in them, in a case of an EMP from a nuclear explosion, for example, they warn that it could fry the chips in a car.
And this is something that could last 400 years, you're saying? Once
well, the forefront, we're talking about something that might just be minutes.
Okay.
And it would be probably preceded by a gravity wave, which would cause earthquakes, seismic events all over the Earth,
okay.
not just in one place. So that might be the first warning, actually, things shaking.
Let me back up Mr. Fraction again to help our viewers understand this and also help me understand this. Does a superwave incorporate a gamma ray burst, or are these two different phenomena?
They're a little different. The gamma ray bursts they talk about are usually from isolated stellar explosions, perhaps very powerful supernova explosions. They have some special physics involved there that the stars are very unusual, like neutron stars colliding and so on.
Okay.
The thing is that whatever they are, we can only guess because they're so far away. Most of the gamma ray bursts that we are picking up come from other galaxies, millions of light years away.
Yes.
There's been only one case. We've observed one that came from within our galaxy. It was a place near the galactic center, but not at the core. And what's unusual there is that about 2 days before the gamma ray burst arrived was the worst seismic event that we've had in 30 years that caused the 2004 Boxer Day tsunami in Malaysia. And over 250,000 people died in that event.
So you're saying that was caused by a gamma ray explosion?
Gamma ray burst. This was the first one they found that was emitted from within our galaxy. It was the most intense that they'd ever observed in the history of gamma ray observatory physics. And the coincidence of being just shortly after the worst earthquake we've had in 40 years, it's, you can do the probabilities, and you come with very small probabilities due to chance.
So you're saying...
Due to chance.
So you're saying this gamma ray versus a superwave, if you were to compare them as events, would you say that the superwave is, it sounds like it's much more long range, much more, it would impact for years at a time,
yeah.
and it's cyclical, as opposed to the gamma ray bursts that maybe aren't explainable?
The gamma ray burst, probably the source star ends up blowing itself up completely into smithereens, so there's no cycle involved. Whereas core explosions, we're dealing with the massive object at the center of the galaxy. Scientists call it a black hole. I don't believe in black holes, and I know other astrophysicists that don't believe in black holes. But I do believe it's a very massive object. It's a core, I believe it's a core of a star. In natural evolution, a star will eject its atmosphere, and you're left with a very dense core that has a density similar to a white dwarf star, which is like, let's say, 1 ton per cubic centimeter, or in extreme case, go to the density of a neutron star, which is a million times greater. We're talking about a spiral galaxy whose core object has evolved to the point where it's starting this outburst cycle. And by the way, that's how a galaxy is formed. These outbursts actually participate in the formation of the galaxy. That's what causes the spiral phenomenon, because without these outbursts, the spiral arms would wind up on themselves. This is a problem which astrophysicists have wondered about. Why don't the spiral arms wind up as it turns? Well, it's because you have these periodic outbursts coming out, and they sort of propel everything.
But do you know what causes that? The periodic...
Yeah, I have a theory that comes out of subquantum kinetics. And in subquantum kinetics, you have a continuous creation of matter and energy. Basically, a violation of the first law of thermodynamics, which is no big deal. Maybe physicists would consider it a big deal. But the point is that we're talking about a level that's 10 orders of magnitude smaller than what they can observe in a laboratory. And in fact, I have suggested an experiment where they can observe it in space with microwave signals between spacecraft. And I've published the amount of the energy increase of a photon over that period of distance. And in fact, they ended up finding this. And it's today called the Pioneer effect.
Okay, so this subquantum kinetic, what do you call particles? It's a theory.
Subquantum kinetics is the name I gave for the physics. It's resulting from taking concepts in system theory, the area I was studying for my PhD work. If you bring systems concepts into physics, and bring, for example, models that have been developed in the area of chemistry, of how chemical waves form, and I realized that these, for example, form a very good model for describing how a particle forms in space. And you find that it solves a lot of problems, which physics had before. Physics traditionally has been based on mechanics, and we're talking about a chemical approach, a chemical reaction approach to physics. Actually, you could say it's alchemical, and there's an ancient, it ties in with ancient ideas too.
Does this relate to hyperdimensional physics and particles being waves, depending on how you look at them?
Okay, it does postulate existence of higher dimensions. The basic idea, which is what steered me into all of this work that I've been doing, was the realization that the basis of existence is flux. This is totally different from what physicists have been teaching. Physicists teach that the basis of existence is structure. There are particles that are somehow bound to each other. Even quarks, they speak of quarks and gluons, the glue that holds them together, so to speak. If they began talking about flux, from their point of view, because physics is a positivist science, they want to observe, to actually say, well, there it is, I observe it. Where is this flux? Well, they can't see it, and you can't see this flux because it's at an etheric level. You postulate an ether as the substrate forming physical phenomena.
A gamma ray burst, basically is a local event that comes from a supernova, which is hugely destructive and powerful. We're quite fortunate not to have any near us. And we've basically mainly seen, if I understand it right, in neighbouring galaxies. But superwave is something different, which is cyclical, is accompanied by gravity waves, accompanied by cosmic ray debris, and lasts quite a long time like a storm, and leaves its imprints and its echoes materially in ice core samples, which is tangible evidence that you have that there's something going on here that's not being recognised. Can you speak to all of that and lay this out simply for people so that they can sort of see the territory we're talking about here?
We also have supernova explosions in our own galaxy, but they're not of the kind of the very powerful that cause these gamma ray bursts. Unless, when we're seeing these gamma ray bursts, what it is just a clump of very energetic particles that happen to come our way at that moment. And when scientists are saying it was very, very powerful, they're saying, imagine that this was the same energy from whatever angle you view this star. And it would end up totaling to a huge astronomical amount of energy. But if it was just a clump of a burst, a collimated burst that happened to come, then you're down to more reasonable levels. So, and the thing is, we don't really know. These things are so far away. But we do know that the supernova explosions that have happened within our galaxy don't really affect us that much unless it happens to be one very close, like within 30 light years, which is a very rare event. But the core explosions are different in that instead of just a fraction of a second for the event, you're talking about anything from several years for a very minor event to 4,000, 5,000 years duration. And the longer events can actually start affecting climate because what they do is they vaporize cometary ice, which is surrounding our solar system, and end up pushing this nebular material into the solar system, and it affects the way light gets to the Earth from the sun. It ends up energizing the sun. It falls onto the sun, and the sun becomes more active and more of a flaring star. And actually, the sun ends up then doing more damage to Earth than the superwave